Welcome back, everyone. Now we're on this lesson called Undetermined Coefficients of Polynomials. Now in the first example, we want to find the parameters for a, b, and c. Now the very first way of doing this is to form up a system of equations. Now to form up these systems of equations, you need to pay close attention to your coefficients. So for the first coefficient, we're talking of degree 2, we have, for coefficient x squared, equation number 1, which is 2a plus b equal to 1. 1 comes from 1 times x squared to the right-hand side. Now for coefficient of x, you have a plus 2b minus c equivalent to 4. Now for the coefficient of a constant, just note that constant is a numerical value in this problem. 3c is equal to 9. 3 times 3 is 9, so c is 3. Now we need to return back to the original two equations, so we plug c into equation number 2. And now we have to simplify it even further. Equation 1 and 2, well, I labeled it after simplifying it differently now. So I have 2a plus b is equal to 1. I had noted that to be little a equation, and a plus 2b is equal to 7 as little b. And this is after doing this simplification of plugging in c into equation 2, I'm doing elimination for this procedure. So little a minus 2b. Now for the second equation, I'm multiplying it by negative 2 to remove the a. I'm terminating the a basically. So now that I've terminated a, I have to do this. B minus 4b is equal to negative 3b. And to the right hand side of that system is 1 minus 14 is equal to negative 13. So here both sides are negative, so they become positives. I solve for b. B is 13 over 3. I finished solving for c and b. The very last thing is I want to solve for a. So I go back to the first equation known as little a. 2a plus b is equal to 1 if b is equal to 13 over 3. So I want to solve for a. But before I solve for a, I want to evaluate for b as well. So I rewrite 1 as 3 over 3 minus 13 over 3, and I end up with negative 10 over 3. 10 and 2 go in together, so they cancel each other out. So now I'm left with a is equal to negative 5 over 3. So the final solutions for this first example are a is equal to negative 5 over 3, b is equal to 13 over 3, and c is equal to 3. Question, guys. Now I want you to verify if this solution is true or not. Now off to the second example. I want to find the variables, the parameters for a and b of a times x minus 1 plus bx equals x minus 3. Yeah, those terms look linear. The x terms I'm talking about. So, first we have done systems of equations for the previous example. Now we're going to go ahead with an alternative method of finding a and b by plugging in some x values. So x is equal to 1. Let's play with that one first. A times 1 minus 1, that collapses into a 0, plus b times 1 is equal to, for the left-hand side, is equal to the right-hand side, which is 1 plus 3. Now 1 plus 3 is equal to 4 for b. If x is equal to 0, now we have a times 0 minus 1, which becomes a negative a, and bx becomes a 0. X on the right-hand side becomes a 0, and then we're left with a times negative 1 is equal to 3. So let's try flipping the sign, and we end up with a equal to negative 3. Now, for plugging in values, you want to make it as easy as possible. Don't overcomplicate it by writing x is equal to 9,000 or x equal to 5,000. We want to keep it as simple as possible so that way you can find your a and find your b by assuming you're just plugging in the zeros of those coefficients. So the goal for finding A and B is plugging in values where we can make the one coefficient 0 and solve for the other unknown coefficient. So solutions for A and B are A is equal to -3, B is a positive 4. Now, the question again is verify if this is true. Here's a hint. Don't be afraid to plug in the answers for your coefficients given in the problem before. Here's some guidelines for determining and obtaining the answers of these unknown undetermined coefficients. By observing what degree the polynomial is, we must determine if you can find the unknown coefficients by deriving a system of equation or just plugging immediate values of x. You can also do this using matrix techniques as well. Be sure to use what works for you. Always make your excellent judgment and know what you think is right. While solving, there's more way to getting the right answer. It doesn't have to be just this way. Now, 3, always check and verify if you got the correct solution, because checking and verifying when doing algebra or pre-calc or calculus, it is very crucial to getting the right solution and to develop a better foundation of the material. Now, for future reference, I hope this lesson will give you a great understanding before you head into more advanced material involving partial fractions, the partial fraction decomposition, integration of partial fractions, well, that's in calculus, or let's suppose you're in differential equations and you're trying to find the methods of undetermined coefficients in a particular solution. This is the lesson you will need to understand to determine the unknown coefficients if they don't seem very obvious right away. Okay guys, this concludes the little lesson on undetermined coefficients. Hope you enjoyed it. Be sure to comment, and if you have any questions, be sure to write on YouTube. Subscribe, let me know. Thank you so much everyone. Enjoy. Take care.